Good morning. Um, Today's lesson is 3.2, talking all about transforming rational functions. So this is taking the equations and things that we've looked at and graphed and talking about how to transform them. Our goals are to be able to describe transformations of a rational function, to be able to write the equation of a transformed rational function, and to choose the appropriate function given a graph. We're going to do all of those things in this lesson. First off here is the parent graph of a rational function. It's simply 1 over x. And when we talk about asymptotes, the vertical asymptote is the y-axis at x equals 0. The horizontal asymptote is the x-axis at y equals 0. So we always have shouldn't say always, but with the parent function, we have two asymptotes, and they are the axes, okay? We're going to use that when we're moving things. I find it's easier to look at the asymptotes and how they moved sometimes than it is to figure out how the function has moved. That can be a little more difficult. So looking at this one here, remember that my parent graph had asymptotes at 0 and 0. This one has a vertical asymptote at x equals 5 and a horizontal asymptote at y equals 2. So I can tell right away that this graph has moved to the right 5 and it has moved up 2. It doesn't appear to have stretched at all. So when I am writing the function for this, I would simply use my standard form here. A would be 1 because it didn't shrink or stretch. Remember, h moves the graph left and right, k moves the graph up and down. So my function would be 1 over x minus 5 plus 2. And that's the function of the graph here. This one has been transformed from the parent function. Remember the transformation rules, okay? H moves the graph left and right, left if it's plus, right if it's minus. K moves the graph up and down, plus for up, minus for down. And A stretches or shrinks the graph, okay? Let's look at this one. So let's describe these transformations. First of all, I'm going to start with my H. My H is -1, or my H is 1, I'm sorry, which means that the graph has moved right 1. Remember, it's always the opposite. Then I look at my K, which is +2, which means the graph has moved up 2. My A shows a stretch of 3. There we go. I just described the transformations. And then if I wanted to, which I don't, I could graph it. Let's try another one here. This time my H is -5, so I've moved left 5, or +5. Remember, we take the opposite, so left 5. My K is -7, so this moved down 7. And then I don't have a stretch or a shrink because A is still 1, but this negative means that this is a flip. Remember that when A is negative, your graph is flipped, okay? And I should probably designate that, oh my, I cannot write this morning. I should probably designate that this is a vertical flip. There we go. Okay. Let's try another one. Maybe I can get my words right on this one. I've got H is +2, which means that I am moving left 2. K is +3, so I'm moving up 3. There is no shrink or stretch, and there is no vertical flip. That is it. I am done. Now we want to write the equation this time. So instead of looking at the equation and describing it, we're going to write the equation, but we're still going to use the same rules again. So let's look at this description here. The parent graph moves 3 left, 2 up, and flips vertically. So I know I'm going to have a fraction. I know I'm going to have an x. 3 left tells me that I need a +3 here in the denominator. 2 up tells me that my k is a 2. And then the vertical flip means this is going to be negative, but it's still 1 because there's no shrink or stretch. This graph is moving down 5 for right and stretching by 3. So let's do the same thing again. We are going to write our function. I actually probably should be calling this g of x, not f of x. That's my bad. It needs to have a different name. I know that it's moving, let's see, 4 to the right, so minus 4. Down 5, so minus 5. And this time I have a stretch by 3, so a is 3 in the numerator. We've done all this before. I'm hoping this makes sense. We've even talked about rationals before. But this is more of like a refresher than anything else, but I'm hoping that this is making sense for you, okay? Now, the last thing we need to be able to do is match the graph to the equation. And this is just use what you know about the asymptotes specifically and about the movements, okay? So looking at this graph, I can see that my asymptotes have moved to the left 4 and down 3. So I'm just going to write this. I've moved left 4. I moved down 3. The points here, don't appear to have really moved. So I'm going to assume there's not really a vertical shrink or a vertical stretch. So I'm just going to write my equation using what I have. So x plus 4 minus 3. And I'm going to leave that top as a 1. Doesn't appear to have stretched. The shrink or stretch can be a little hard to tell from the graph, so I'm not going to be super picky about it. If there's a shrink or a stretch, you should be able to clearly see what that is. In this case, there isn't one. These points are still in the same spot that they always are, so I think it's fine. Now looking at this next one, let's write the function. My asymptote has moved to the right 1, and my horizontal has moved up 1, 2, 3. Doesn't appear to be a stretch at all, so I'm going to write my function 1 over x minus 1 plus 3. So there's a couple different pieces here that you need to be able to do. Can you describe the different movements, either from a graph or from an equation? Can you write the equation? And can you identify the asymptotes and the different pieces in order to transform rational functions? I hope the answer is yes. I have some practice for you. There is an assignment on Schoology. Please make sure you do that. And I will see you all soon.